Welcome all of you to all the participants and a warm good morning to all. Welcome to the last day of the AICTE sponsored training program on AI-powered solutions for healthcare innovation. This is the last day of this STTP as well as the last day of this year 2020. Today our invited speaker is Mr. Pradeep K. Sir is a data specialist working at Emphasis Bangalore. Sir will be handling the hands-on session in the forenoon as well as the afternoon session today. Welcome, sir. Welcome to this session on behalf of the management, the participants and the teaching faculty of KCG College of Technology. A warm welcome to you, sir.
Yeah, thank you very much. Okay, so good morning to everyone. This is Pradeep, and I currently works as a assistant manager data science at Emphasis Limited in Bangalore. So give me a minute. I'll be sharing my screen, then we will start our discussion. Everyone could able to see my screen. If there was any issues, kindly let me know.
Not still visible, sir. PPT have you shared?
Yeah, I've shared the PPT.
Yes. Visible, sir.
Okay, fine. Thank you. Um, yeah, so the topic today, which was given to me, is like how to build an intelligent classification model using a healthcare data set, which I have taken is a diabetes with the help of machine learning algorithms, very specifically logistic. We are going to discuss today, right? So I'll just give a roadmap of today's session. So we'll be starting with overview of classification that I think you might be knowing everything. So I'll start with logistic and I'll give some 10 minutes of math behind that logistic. Excuse me, sorry. Then so I'll give a glimpse of the life cycle of a machine learning model, how which has to be built with the help of the all Python libraries, and then we start to write a script how the model is going to be built uh, in a Python. Then we'll see how the performance has to be calculated and how it makes an impact onto the model with your real-time scenarios. And then hyperparameter fine tuning, which is more significant part of this era. Like fine tuning is always the mandatory one and critical thing which we need to take forward into the real-time production. Because when you develop any model, all the model will be performing in certain level, but we don't know whether that could be the best performing of the model. So there was no idea, right? So we go with fine tuning of the hyperparameter in order to optimize the performance of your model. All right. So completely hands-on. Just bear with me, like for a 15 to 20 minutes of time. I'll just give a overview. Then we directly land into the hands-on part, where in which you can have a look onto it. And finally, we have a QA part. So QA is not should be the final. Like at any point of time, wherever you get clarity, and just you can unmute yourself. Right. So that's the agenda, right? So I'll directly go with some kind of math notations, right? So, and one more request I put you all into you, like it shouldn't be a like kind of a session only, teaching and learning, listening. Rather, it could be a discussion. I'll be so happy for it. So, and even if you are knowing something, you can come up and you can share your views. And similarly, we drive the session, as a discussion. I don't want to be a lecture, right? So a logistic. So everybody knows like a logistic regret. I don't want to go into the fundamentals, basics that you have been covered last 5 days of the tenure. So directly we go with the logistic. So logistic is actually used for what classification. What exactly the classification? So I should find out. Hey, he's a boy or girl, right? He's a ARB, right? And whether he's A or B or C, right? So we need to we need to go and predict whether 1 minute. So excuse me, ma'am, kindly go with mute.
Yes, 1 second.
Yeah, please, please.
Participants, please mute yourself.
Okay, fine. Yeah, thank you. Still, someone was unmuted. Okay.
Participants are requested to mute your. Sir, 1 second, I'll mute everyone.
Yeah, no problem, no problem. I'll wait.
Okay, now can you unmute yourself and speak? I have muted the presenter also. Can you unmute yourself and speak, sir? Pradeep, sir?
Yeah, can you hear me now?
Yes, yes. Okay.
Yeah, thank you. Okay. Yeah, fine. So, classification is a technique or kind of algorithm wherein which we could able to classify or discriminate something ERB or boy or girl. So, classification can be applied into two varieties. One is binary and multi-classes. Right. So binary is something like, as I given an example, like A or B. So multi-class is nothing but more than two category. If you have, then you go with multi-classes. So since we are taking a logistic, so logistic is primarily used for binary classifications. So always when you have the data which has to be classified as a binary category, then you go with blindly, you can go with the logistic. Since logistic is working fine, rather than all the algorithms, uh, you know, if your outcome is a binary, right? If your target is a binary, but this is the suggestions. 90% of the time logistic regression will be working fine for you in case of binary classification, but it does not mean that like always the logistic will be performing good. So sometimes it depends on data. It depends on data nature. Okay, so depends on data nature. 90% of the time LR is performing good. Some rare cases, other algorithms might be, doing good. So the other algorithms might be a decision tree, it might be a, random forest, it might be a Navi bias, it might be a like support vector machines. So these are the, rest of the classifier, so which we'll be using in the in terms of making a, a prediction model, right? So this is the quite fundamentals that we should know it, right? So and you might be asking a question, why can't we put LR in terms of a multi-classification? Does the logistic regression will classify multi-classes? Of course it can classify, but with certain limitations. There are certain limitations. All right. So when we have a multi-classes, we go with support vector machine or decision tree random forest. Since SVM and decision tree are the very finest algorithm to do the multi-classes. So when we have a binary outcome in your data, then we go with the logistic. All right. I hope that you got some idea on it. And what was the, there are certain properties data should abide. So you know very well. So in order to work with the classification, your data should be a labeled one, labeled data, or you should have labeled feature. All right. And the second part, the second property of you know your data should be either uh, continuous or discrete. Your values, your instances of your features must be continuous or discrete, and it your information it must be real values. What exactly the real values is, we always used to keep like some positive values, some whole number, right? So for example, let me take there is a feature BMI, right, body mass index. So it shouldn't, it should be 20, 20, 35, 40. It shouldn't be minus 10. All right. In case this BMI holds minus 10, this minus 10 shouldn't keep into this features. All right. Because sometimes this is the properties of the information what you have in your file, but sometimes the real data should have the negative values in a features. In case if we have, you have to clean it up, you have to clean it up. That is the thing. But if you have real values in your features, then your model working fine at all this distinct stages, right? So and then you should specify the target, right? You should specify the target. So for example, let me take a scenario like you have information like A, B, C, D are the input features and T is the target. So you should, 1 minute, you have to specify what are all the input features in it, what are all the input, so what is the output. So you have to specify this T as your target. So without specifying the target, you never build a classification model, right? So that's the, you have to specify your target, right? And one more thing, the target must be a category. category of features. All right. So when you want to work with a linear regression, your target should, it is not necessary that to be a category features. Whereas when you want to work with a classification, your target's supposed to be a category. You know what is category, right? So you shouldn't have continuous value in it. You should have the discrete value in the category features. All right. So this is the data property we should keep. We should check before proceeding to build any model whether all these basic properties have been satisfied by your data file or not. All right. So now I go with what exactly the logistic regression. So we'll start with some you know, math behind logistic regression. We all know it. What is the line equation of the linear regression? So y equal to mx plus c, wherein which this m is the slope and c is the constant. Using this, you'll be predicting the y. So y is the predicting variable. So this was the base equations, right? Using this, we'll be forming. You'll be forming y dash, right? So using this baseline equation, we'll be finding a y dash. Y dash is actually predicting. So instead of m, you'll be getting some value 0.4. X is the input that won't be changing, and c is 1.2, something like that. So for every x value, the new y dash is being calculated based on the historical observations, right? So this is the equation to be used to understand the historical information about your data or informations based on the historical observations. So we'll be generating new derivatives of your information. Based on that, the future values are going to be predicted. In case the x might be anything, right? So if you want to know the x equal to 10, what could be the y value? So you put this x value here and you'll be finding the future value of y, that is what y dash, right? So here y dash equal to 0.4 into 10 plus 1.2. So I could say it is a 4 plus 1.2, it is 5.2. So new y dash is going to be 5.2. So since it is the numeric value predictions, that's how linear regression is working. Now, a logistic is the extensive of the linear regressions. All right. So extensive of the extents in terms of a logistic regressions. All right. Okay. So I'll just zoom out so that we can keep everything into one places. Yeah. So what actually the logistic regression is? Uh, a logistic regression predicts the probability of an outcome that can have only the two values. That's what I have told, like, which could be used for binary or classification. All right. So I could just redefine it. The sigmoid, sigmoid equation. So similar to this y equal to mx plus c, there was a, because you don't do much research on how come mx plus c came out, right? It has lot of derivatives and use cases, test cases. Out of that, the mathematicians have been derived it, which is quite good at all the point of time, right? So we never change make any changes over it because it was proven when and universally it was accepted kind of a derivation wherein which all the algorithms are working. Similarly, sigmoid equation has gone into n number of thought process and it has been involved into a lot of test cases, and finally they have been derived this logistic regressions. So sigmoid equation is nothing but we want to classify, right? Let us take there was features called target, in which you have 0 1 0 1. So you have to predict right whether the given input is belongs to 0 or 1. All right, this has to be forecasted, right? So we have to calculate the probability, all right? That is what p is nothing but probability, all right? So 1 divided by 1 plus e power minus, here you have to write your line equations, all right? So you can, we can see what is this actually. This entire part is, you know, linear regression, linear regression. So why the name came as to logistic, the sense we'll be performing logarithmic operation onto this equations, all right? So this is the final equation by which you can substitute as how you'll be doing in the linear regression. Always x is the input. In case if you have only one feature x, I'll be writing this into multiple features. So 1 plus e power put minus, and if you have multiple features, multiple slopes are going to be built, right? So m1 x1 plus m2 x2 plus m3 x3 and plus, what is that, mn xn, then finally plus constant c, all right? This is the equation when you have multiple input features. This is the equation, generic way of representing a sigmoid equations like this, all right? So this mx plus z always generate a, what is that? This line equations, when you take this line equation, it will create a straight line in your mathematical region of x and y. I hope that you could follow. And please let me know if I'm, because I thought like you people have the fundamentals and basics. That's what I only talk about that today's part math, right? So I haven't discussed the I haven't gone into the how y equal to mx plus c came out and what are the significant over there. I haven't spent my time to over there. So I just want to focus here how the logistic is going to be classified, and why I'm spending some time in math, right? So when you do write any article or research article, so mathematics plays a vital role. So because if you know the mathematical, then you could identify which hyperparameter are significant to your model, so which has to be fine tuned. So you have to get that point. All right. So meanwhile, if I'm going very fast or something is not understandable, please let me know. So I put some time to make you understand. All right. So this is the equations. So now I'll just create a line for your better understanding. So let us take all right. So this is x and y. All right. So when you take y equal to mx plus the linear regression will be creating a straight line. All right. So it will create a straight line. So with the straight line you can't able to classify a or b, something like that. All right. So this is what y equal to mx plus c. All right. This straight line will be created. So I've told you like p equal to 1 divided by 1 plus e power mx plus b. This is the sigmoid equations which creates a sigmoid curve as like this. 1 minute, yeah. Sigmoid curve. So you just bear with me. I don't think so whether the sigmoid curve is coming out clearly or not. Okay, somehow I've drawn it actually. All right, this is what sigmoid curve. This is being drawn or came out by this equations. All right. So with this, sometimes you might be asking like how you might be wondering how the uh, uh, classes are going to be classified. So here by default the logistic regression will have the threshold level. So we'll have the The threshold level is going to be 0.5. So always the p value is going to be 0 to 1, right? The probability value takes place 0 to 1, not any other values. So here the default threshold value is 0.5, right? So the probability of your classes, let us take, we have A and B, or else you could see here like I'll just put something, what is that? All right, it's all plus and something, it's all minus. All right. So how these plus and minus are being classified with the help of this threshold value 0.5. So whenever your p value is greater than 0.5, which is classified as plus, whenever your p value is less than 0.5, your data is being classified as minus. As such, it will be working. So the threshold is 0.5. All right, it is a default threshold value. Maybe if you know the data very well, sometimes you may change the threshold value of this logistic regression, which is not actually fixed or static. All right, so defaultly when you call the algorithm, it is being taken as a 0.5 as a threshold value. But if you wish, sometimes you can change, this is going to be a this point, or you may have this point as your threshold. You can have zero point 0.4, you can have 0.7. That's up to your wish. All right. So as such, it is working. So please let me know if you have any doubts on it or any queries on it. And I'll just give some basic mathematics, right? So we know it, a probability. So we know probability, right? So what is the probability? The chances of events that you are getting is the probability, right? The amount of chances. So let's take uh, we have a two probability. One is you know success and failure. I hope that you could remember. Success I could always represent P, and failure I could represent always Q. As per the probability law, so the P plus Q is always 1. That you might be remembering. All right. So with this, how do I refer? So always I want to convert everything into one single variable. So uh, so here if you take this problem plus or minus, if we say plus is a success, then obviously minus is a failure. All right, these are two classes: plus is success and minus is failure. One minute, sorry. So this is going to be exactly depicted in terms of a mathematical way. All right. So we want to find out the ratio, right? Ratio between the plus and minus. Sorry, ratio or probability between the plus and minus. So how the sigmoid equation is came out, I could write it. So I could say the ratio is success and failure, right? Which can be mapped out plus or minus. This is going to be depicted as a P and Q. What is the success variable? P. What is the failure variable? Q, right? We shouldn't write Q here. Instead of Q, I can write Q equal to 1 minus P. Right. So we supposed to put instead of failure, I could put 1 minus P equal to. All right. So this is equal to exponential of your line equation, mx plus b. All right. So I've just taken into the direct step here. It has a lot of mathematics. How the exponential came out here, it was a bigger story. All right. I just have some log idea how it came up. The ratio between probability, the ratio between success and failure, the ratio between your category plus category and minus category, which is assigned as the exponential of mx plus b. This is the line equation. 1 minute, sorry. Yeah. So now we have to eliminate the exponential term. All right. So how the exponential term are going to be eliminated when you take apply you know natural logarithm, so in both sides. All right, so when you are applying, right, 1 minus p, now your exponential is it's gone out, so now you have mx plus b. All right, now you have logarithmic, but what was our ultimate objective is we have to derive the equation in terms of a p, right? We want to put everything in terms of a p, right? So again, you go and if you have a look onto it, use the logarithmic way of solving a problem, then finally you'll be getting this as 1 divided by 1 plus e power minus mx plus b. All right, so I haven't I just don't want to go into this equation solving. It might be taking a lot of time. So from this directly it comes out, right? So if you want to know how the 1 divided by 1 plus e power minus mx plus b came out from this natural logarithmic, you have to invest some time and get it done. All right, so this was a little history or backbone of your logistic. All right, so I hope that how the p-value is going to be developed. So p is nothing but the probability value. So based on the p-value, your categories are going to be classified. So you have data plus and minus, so you'll be getting a probability of, because this is the category 1, right? You have a lot of inputs here, so you have a lot of inputs, 1 2 3 4, here 5 6 1 2. So based on these inputs you'll be recognizing it as plus. Based on these inputs you will be recognizing it as minus. So we want to find out the probability. What is the probability of plus? You'll be getting 0.8, and probability of minus definitely 0.2. All right, so and when you want to classify this, no, you don't get actually two probability, you'll be getting the only one. So if you get 0.8 of any int, then zero point 0.8 is greater than, right? What is the probability value? 0.8, which is greater than 0.5. So definitely this condition is true, so it has been classified as plus. Similarly, if you take this input and if you want to classify what category depends to either plus or minus, and you'll be putting all the way into this equation, and you'll be getting a value as p equal to 0.2. Then 0.2 is lesser than 0.5, so obviously it belongs to minus. As such, your category are going to be classified. Okay, so I'll just pause a minute, like have any Q&A? Okay, so assume that you people don't have any problem here. I'll be moving ahead. So now the time is 10:40. So give me a 5 minutes of time, then we'll move on to the answer part. Okay, so the next is what is the life cycle of building a model? Right. So initially, we have data. So you'll be having data. So it might be a structured or unstructured, and sometimes hybrid. But keep in mind always the machine learning algorithm will accept only the structured data. It won't accept unstructured hybrid. If you want to put unstructured hybrid into your model, then you have to convert those model into the structured way using uh, you know framework called Hadoop. All right, so Hadoop is the big data tool. It is a one of the tool, as like that we have plenty of tools in the market. So after that your data comes in, so you have to what is that, you have to pre-process it. So pre-process in the sense sometimes your data will might be not in the proper way, You have to clean up. That a pre-process includes a lot of meaning like cleaning, you know, transform and integration. All right, and we can say a lot of things over here, right? And in machine learning or principle in machine learning life cycle, we used to call it as a EDA. So exploratory data analysis, the main objective of EDA is to understand the nature of data. All right. So we used to specify, we used to spend, if you assume that you know 100% of the time, then we used to spend our time 40% of the time we used to spend in just you know doing EDS, since wherein which we'll be deciding whether the data what we are acquiring to build a model is significant or not. So if the data is not good in nature, then there is no use to take it forward and making a model and doing a lot of stuffs over there. So it's completely cost expensive. I- when you are taking or taking forward your useless data. Am I right? So very clearly, very catchily, I can say in a nutshell, it is whether you should identify useful or useless, right? That's the reason why most of the people are spending their much time on EDA. So if you feel like, if you find the evidence that this data is useless, then rest of the 60% of the time are going to be saved, and just imagine about the expenses, right? So everything is going to be minimized. So that's the reason why this pre-processing is always, it's much needed. The next thing is, I could say it's once the pre-processing is done, you make a model. So model building. So in a model building, you have to split your records, split your data for training and testing. So split your records for training and testing. Why do we want to split, train and test? You know with the train data you make a model, with the text data you can evaluate how far the model is working fine or not, right? So that's the reason why we want to split your records in train and test. Depends on data. I always used to keep 80% for training and 20% testing. All right. So after, once the model is built, then you have to evaluate it. All right, so you have to evaluate. So what is the accuracy of it? So it depends on algorithm. There are a lot of way to estimate the performance of it. So in a classification, always the evaluation is going to be done by confusion matrix, right? And classification report. So I could say the parameters or the metrics what we uses to evaluate the model is you know precision, recall, and you know what is that, precision, recall, and accuracy. All right, so using these metrics you can have an idea how good your model is performing with the test data, right? So when you are not happy with the performance, right, when you are not happy with the performance what you are getting from the model, then you can go for a, what is that, you go for optimization. So right, you go for optimization is nothing but just fine tuning the parameter. So what is the parameter here? Hyperparameter in the logistic regression. You can clearly, I can say this is the hyperparameter, this is the hyperparameter. You never and ever change any of the values without which. So when the momentum, when you change the value of the slope and a constant, obviously your p-value is changing. All right. So what could be the appropriate value we can place for slope and a constant in order to improve the performance of the model? That's the tricky here. So here the hyperparameter is just slope and a constant. This could be the common for linear regression, right? So linear regression, all right, because in logistic regression when you substitute any value here, always the p-value is going to be lies between 0 to 1. All right, so that's what we used to say, it is a sigmoid equations, right? So when you want to change this, when you want to have the outcome ranges -1 to +1, the same sigmoid is going to be renamed as tannage. All right, so okay, I don't want to make him into complex, so we go with, all right. I just thought of you like what is hyperparameter. Right now you got to understand what is hyperparameter, and manually you don't we don't have facilitate to change the values of the slope and constant. It is highly impossible because manually you can't get the right value. So that we have a lot of techniques to fine tuning the hyperparameter. That's what we have a technique called you know ensemble. So ensemble, I don't want to talk much on the ensembling. So if time permits, I'll just include some of the ensembling algorithms, right? I could say random forest is the ensembling, all right, and bagging classifier is the ensembling. These are the some of the ensemblers. Okay, so I've done my part, and I will go with the hands-on. Sorry for taking the too much of time, the the theoretical part. So if you have any doubts, you can ask me at all. Okay, so give me some time. I'll be opening a new file. Okay, so I'll tell you the data. What I'm going to use here is like a diabetes data set that you can. 1 minute, I can show you where you can download it. You want, you can work with me parallelly, or else you take data and observe the steps, and we can work it out little later. All right, so you can put here pima diabetes data set. It will take you into the gaggle. I hope that everyone knows about gaggle. Gaggle is the uh, you know international data repository which is owned by Google, and which is the subsidiary of the Google. It's completely open source. All the data are freely available. You can download and make use of it. So you can just download this part. You have to sign in out, right? So you must be signed in. Then you can download. If you click start downloading, all right, and you can find option here. You can see here it has been downloaded as a archive file, right? This is the file I'm using here for making a prediction model right away. So you can download it. All right, get to Gaggle and enter pima Indian diabetes data set. You'll be get the data. Okay, fine. So I'll go to this. So I will uh, logistic regression. So as everybody knows, the basic libraries, I'm going to import it. So yeah, I if you people wish, you can do it parallelly, right? Because if you are well versed with this packages and all, if you have been set it up all the infrastructure, like you have been installed anaconda python, and if you keep installed every packages, then you can start working parallelly. Else you can just observe it. Import matplot lib.pyplot. Import, I'm going to use Seaborn as SMS, right? So give me a minute. Just, and I'll show you some of the data file. I'll directly pick it up. Let's wait for a while. The packages are getting loaded. This star indicates that the libraries are importing from the Anaconda framework to this the environment where we are working. 1 minute. It takes time. It's loading. Just wait for a while. Yeah, it's, now it's checking. And I'll be doing some of the basic EDA here. I hope we do have time. Still, we have almost for 1 hour time. So I'll do basic EDA and upon every graph, what is the impact? What actually we'll be learning when you are doing EDA. Sorry for that. It takes too much of time. So let's write it. Pandas will be supporting all the way, all the file format. Alright, so I'll just open where the file is going to be. Yeah, there was a data. So here the file name is diabetes. Paste here. Yeah, give me a minute. So it takes too much of time just to loading. A minute. So I'll just stop it, interrupt the kernel and re-execute it. Okay, fine, it's done. So now I'll be taking this data, diabetes underscore NA. Right. So I'll just show you the data. All right. So this is the information I have taken. As you can see here, this is the purely women pregnancy diabetes data set. All right. So women data set. The women, how many pregnancies she has given, and what is this glucose level, blood pressure, skin thickness, insulin, BMI, and predicate function, age, based on these input. And already the doctor have been, this is actually the actual data, right? It is not a modified or cook-up data, it is the actual informations. So the outcome, the doctor has classified them or marked them as a 1. So 1 stands for they have diabetes, 0 they do not have the diabetes. All right. So based on this we want to build a model. uh, if any of the women's are coming out to check whether she has diabetes or not, they can enter all these input parameters into this model. They can get it know whether they have diabetes or not. They don't need to go for doctor and wait for the consultant just for knowing whether she has diabetes, all right, or not. So just it makes the automation. It's where actually automation starts, right? Where the manpower is going to be eliminated. Uh, that is the point where the automations. This is the one of the simple automations with the help of the machine learning algorithms. All right. Okay, fine. So I'll just show you what is the basic EDA. We want to know about the size of it. So I can give shape. So when you are calling the shape, it returns how many number of rows and columns are there. As you see, 768 rows and 9 features are there. All right, and if you want to more information about the data, you can get it here. Info is the method to know about us. So this is the data and memory. How many float features are there, how many int features are there, number features, we got it. And the first I go with the what is that histogram. I'll do some basic EDA. All right, the basic EDAs I go with histogram. So you can call hist is the method. Hist is the method, and you can define the size of the graph so that it will be fine for you. And I'll be executing here. You can see here. This is the actually histogram. All right. So 1 minute. Okay. So what is the use of histogram? So histogram is always used, to uh, know the density of the records. All right. So I think most of you people have worked with the images and all. So we should know what is the density of the information at which regions, right? So accordingly we do compress it. When we go for a image compression or image processing, most of you people would have been came across the histogram. So histogram is the kind of a graph. It will give where actually the density is high, at which point of the information density is very low. All right, so this is the let me explain you age. You can see at the start with 20 to 80. This is the bin values, right? So actually before some years, like when you want to build or create a histogram, we have to set up the bin size and everything manually, and then you have to get the histogram. Now automatically the bin value is going to be decided by the pandas itself, right? So you can see here the records are very high. The age of 21 to 30 peoples, 21 to 30 at the age, your records is 300. So when the age are increasing, right, the age are increasing, you can see here the density of the information or records are decreasing. So what is the actual inferences out of this histogram is with this age, right? 20 moderately I can take 20 to 40. I have some significant amount of historical observation, whereas you can see 60 to 70 have only few records. So you can see 80 I have no records, right? 80 and above have no records. So what actually will be understanding out of this age histogram is when you build a forecasting model, classification model, your model won't be working fine for the age of greater than 60, because we lacks with samples. We don't have enough samples to predict, right? So at which age of peoples the model is working greatly. So from 20 to 40 age of peoples, the forecasting models will be working fine. All right, so that is the inferences that you can take out from the histogram. Right. So you have to invest your time, and you have to make a note of each and every features, right? Because being as a machine learning engineer or data analyst or data scientist, when you do build model, you're supposed to show the evidence of the people, right? If we have to you have to convince your bosses or manager how you'll be saying this is the maximum performance. So you have to take the evidence. So right, you have to take up this graph and project it, and you have to convince them. See, we are very lax with the information. The people whose ages is greater than 70 and 40 to 60, we have very less number of records. So the prediction of the age between 40 to 60 is somewhat okay, not good. The prediction is always doing better the age of 20 to 30 or 35. So that is the inferences, right? So now you got to understand at which age of people's your forecasting model is going to be working fine. Say 20 to 30 and moderately 30 to 50. So above the age of peoples, if somebody's are coming and checking their they want to know whether they have diabetes or not, for them the results what the machine is giving is not all 100% correct. So that's the inferences you can take out from the histogram. And I just want to put the 5 point summary. As you can see here, this is the statistical summary of your information. Count, mean, standard deviation, and minimum value. 25 percentile of data belongs to what value, 50% of data belongs to what value, 75% max. So these are the basic statistics which is pre-computed by the pandas, and whenever the algorithms needs these statistical values, the algorithm won't ask you to give me a mean value or give me a standard deviation. It will take it from the pandas itself. That's the beauty in these libraries. All the libraries are interconnected, right? So because numpy has been pandas has been installed on top of numpy, and numpy has been installed on top of scipy. The reason why why we have interfaced all these packages is to make the interdependency into the model, right? Okay, so and what is the outlier? That next thing is very very significant thing, outlier, right? I want to spend some time here to make you all understand the outlier, right? So yeah, you know very well the normal distributions, right? What is normal distributions? So when we have the bell curve, all right, this is normal distribution. Always this point, all right, this is the point, is the mean mu, right? So, all right, so this is the point, and this is the point. Statistically we have defined this is mu plus sigma, this is mu minus sigma. So as per the normal distribution statistics, distribution probability distribution statistics, in this region, all right, we have 65% of data. I, I'm not accurate actually, 65 to 66 something else, right? Let us take roughly 65% of data are distributed in this region. And then you take this is the point and this is the point. All right. So across these, right, these lines, almost 95% of the data was distributed. This was taken mu minus 2 sigma. This is mu plus 2 sigma. Similarly, you have another point, right? This is mu plus 3 sigma. This is mu minus 3 sigma. And I hope you know it, right? So mean is the central tendency, right? Or it you specify the central values. Sigma is what? Deviation. So deviation is what? Let us take like 1, 2, 3, 4, 5. What is the mean value of all the things? I think 1 to 5 is 9, 10, 15. 15 by 5 is 3 is the mean value, right? 3 is the mean value of these 5 instances. So, and what is actually this mu plus sigma is saying? All right. What is the this is the mean value, and standard deviation is, what is standard deviation? What is the difference between 1 to 3? This is the actual instances, right? Difference is 1 minus 3, it's 2, right? This is 1, this is 0, this is 1, this is 2. So add all the things, 2 plus 1, 3, 3 plus 3, 6, 6 divided by 5 might be 1 point something else. So this is the deviations, right? Standard deviations. Actually, we have to square it up. When you want to add the, when you want to find out the standard deviation, we have to square it and then take the square root. So roughly I'll be telling, right? You know very well why we want to take up the squares. What is this? This is x, right? This is x bar. What is the formula for calculating is x minus x bar, that whole square. All right. So summation of I equal to 1 to n x minus x bar, that whole square. What is that? This is divided by n is the number of instances. So as such also you can find out the standard deviations. All right, so why we want to take the square of, like, you can see here 1 minus 3, you will be getting minus 2, right? The difference is not been a minus 2, so we have to eliminate the minus term in the equations, right? The standard deviation shouldn't be a negative, so it's always going to be a positive value. That's the reason we want to square it up. And then this is what sigma, right? Sigma square is equal something like this. When you want to find sigma, take the square root of entire thing, you'll be getting it. So that's the way of, that's the procedure, way of finding the standard deviation. Standard deviation is averagely what is the deviation of each and every input with its mean value. All right, that is the standard deviation. So if you take 1.2 something like that, all right, so mean is 3. What is the standard deviations? 1.2. So when I say mean plus 1.2, so what is the value? This is 4.2. Mean minus 1.2, it says like 2.8. So this is 2.8, this is 4.2. Within this ranges, statistically they have proven 65% of data belongs to this region. So how the outliers are, let me come at the point. Outliers, right? So I'll be saying like minus mu minus 2 sigma to mu plus 2 sigma. You can come up here 2.8, 4.2, 2.8 and 4.2, which means that this is the values 2, 3, 4, which was into this region, 65% of region. Let us take mu plus 2 sigma, mu minus 2 sigma. Mu plus 2 sigma, 2 into 1.2. I'll be writing 3 plus 2 sigma. 2 into 1.2. What is the value? Let us take 2.4. This is 5.4. Right? So this value is 5.4. What is the next thing? 3 minus what is that? 2.4. The value is going to be something like this, 0 0.6, right? So this is what 0 0.6. So in this region, almost 95% of data should be there. You can see here, what is 0 0.6? This is the point. What is 5.4? This is the point. So now in this mu minus 2 sigma to mu plus 2 sigma, all the values we have been covered. Now in case you have the values in a x feature 10, according to the status, 10 is the uncertainty value, right? Which is not coinciding this range of value 1 to 5. So 10 has the huge differences. What is the differences from the standard mean value? 3 minus 10, right? What is the difference? 7. What was the actual standard deviation? 1.2. It is a huge differences in the normal standard deviation, so that this 10 is going to be considered as a noise or or extreme data point, right? This 10 supposed to be in this region. This is the data point in the distribution. So almost 99% of the data was into this region according to this statistics, but you have another data point 10 which were located out of this, this normal distribution, so that I'll be calling it as noise or outlier or extreme points, right? Or uncertainty. Either of them you can refer it, right? So here, this is the way the outlier are going to be calculated. uh, how this is going to be done in a things. You can see it's very simple. Est of fixed size of 10 comma 8. What happened? Sorry, not not a hist, right? This is box plot. 1 minute. Box plot of fixed size equal to 10 comma, oh, 1 minute. You can see here, this is the box plot. All these circles, right? That circles are the outliers. These are the extreme data points. Right. So the outliers can be understood with the help of normal distribution. The outlier can be understood with the help of the 5-point summary. Right. 5-point summary is nothing but this is the 5-point summary. So minimum 25% in the first quartile, second quartile, third quartile, maximum value. So with this also you can able to understand it. Right. So all these points are the extreme points. Right. So this black circle is the outlier. The next I could explain, I could create a outlier graph by just calling for a single features. So I just now using the Seaborn, which is more interactive than the Matplotlib. Box plot of data of, let me take pregnancy. You can see here, this is the box plot, right? So you have 3 points as the outliers. Then we have another discussion, like whether we you got it, you have a outliers in this features, right? You got to understand. Then what we do with the outliers? Should I remove the outliers or should I retain the outliers? If I want to remove, should I remove all the outliers, or is there any kind of thresholds is there to remove or to retain? It's subject to discussion. All right. So depends on the domain knowledge, depends on the data. All right. Any machine learning engineer should take their own decision whether they can keep, or whether they can retain, or whether they can drop, whether they can retain partial amount of outliers, whether they can retain full outliers. So it's completely subject to discussion. So there, because in the outlier handling there is no prompt rule has to be defined to retain or to drop it. It's completely domain experience, right? As such, you can drop for all the features. What is that? Let me take age. Age is there. Yeah. Oh, box plot. Yeah, we should write data of right. See, so as like that you have to make a box plot to know about the outliers. So I'm not going into the detailed discussion of outliers. All right. And then I'll just give it to you. Right. So what is that? Um, Yeah, we'll get correlation. So you know very well the correlation. So based on the correlation, you may have a look onto the significance of the features. So I'll put this correlation in terms of a graph. So we have to call the heat map from the Seaborn. So in which you have to call data.correlation and write annotate. Annotation is nothing but just displaying the value on top of the graph, displaying the correlation value. So true, and you have to specify the maximum and minimum vertex. Minimum value is -1 because correlation is going to be -1 to +1. So the maximum vertex is going to be the +1. We can see here the heat map are going to be created. All right. So and then we have to check it out whether do we have a missing values or not. All right. So finding the missing value is nothing but the empty cell of your data file, right? So for that, data dot is na dot sum. If I give, it will return the missing values future wise. You can see here we have a missing value in some features. Pregnancies, we have two missing value here, 1 1 1. So with this missing value, if you take and build a model, you'll be throws an error. All right. So the algorithm, when you want to apply algorithm, the algorithm needs cleaned data. All right. So with this missing value, if you give your data to the algorithm, the algorithm won't build a model. So all right. So I'll give we have to you know clean it up. The missing value has to be filled with some meaningful way. Right. So as you can see, right, you can see there was a NAND, right? This is the missing value here, here missing value and missing value. Missing value is going to be done with the help of many things. Data dot, the method name is fill NA. Fill NA, you can pass any values here. If I pass 100, right, you can see here going to be filled anywhere. Right? This nan is filled by 100. This nan is filled by 100. This nan is filled by 100. But this 100 is not significant, right? So we have to fill up the appropriate value in the places. So appropriate value in the sense I could find the mean value of every features and I can fill up here, right? That is the one possibilities. Take the mean value and fill all the missing places. It might be a some logical way of filling the missing places. Or else either I can copy the previous value, I can put up here, or the next value 8 by 8 I can put up here. That might be also logic. All right. So the pregnancies are going to be 681, right? If I substitute 100, there is no sense in filling the missing value. So filling the missing value should be done with some logic. All right. So the one thing is find a mean and put up here. Other one is take the previous value and fill the missing places, or else take the forward value and back it and fill it up here. So there are plenty of ways. So I can show it up all the ways. Data dot um, fill na of data dot mean. So I'll be calling mean. You can see here the mean is going to be filled here, right? So actually this ended, right? Mean is 3.84 is going to be filled in the missing places. So in all the way mean is going to be filled. This is the one way, or else other way I'll be calling a method called I can take this 6 and fill up here. So for that we have a method called, what is that? Method is equal to forward filling, f fill. Yeah, so it's a what a forward filling method is equal to 1 minute. Oh, sorry. The method has to be no 1 minute. Yeah. So B fill, you can see here backward, right? It has been taken and filled up this NaN places. So this is what backward filling should know, right? And similarly, there is a another way is forward filling. Oh, sorry, yeah, forward filling, or else you can see simply method is equal to pad. Pad is actually forward filling. You can see it. 6 is going to be taken and put into the missing places. So because still there are a lot of ways are there to fill up the missing values, so this is quite enough for you as of now. All right, so as such I'll be handling, so I'm going to store this method, I can take df data dot fill any of data, sorry, method equal to, I could say simply pad. All right, now the uh, you know uh, the the filled missing value is being stored in df. All right, so now I'm going to check is there any missing value in df. I've just copied everything into the df dot is na of dot sum. Let us check is there any missing values. You can see there was no missing values, right? We go with, and before that I want to uh, have a look onto some of the basic EDA. You want to know what is the uh, how about the outcome frequency, whether the zeros and ones are balanced or not. All right, I want to know what is the count, how many number of records are belongs to 1 and 0. So sns dot count plot of data of outcome, you can see here. So 0 is I actually. So it is an imbalanced data. When the data is imbalanced, obviously, outcome is going to be slight sticky. So we have to balance it. All right. Okay. Then SNS dot, you may, yeah, I may put, there is a thing called join plot of data of pregnancy, comma, data of outcome. You can see here joint plot in the sense histogram and the scatter plot. All right, this is in a one graph you will be having two graphs, right? So pregnancies, instead of this I may put age comma and uh, 1 minute. Right, so yeah, right. So as like that you can build a number of graphs. So I just want to show you what is the pair plot, so multivariate analysis. All right, so that I can skip, right? I'll go with the model building. So this is the basic EDA. All right, still lot more methods are there to in EDA actually. So due to some time constraint, or because I'll move on to the model building. All right, so data splitting. The second step, as I told, data split for train and test. So I'm importing the packages from sklearn dot model selection. Yeah, 1 minute. Yeah, model selection import. There is a method called train underscore test underscore. Right. Even we can manually split also, but there was a method. This method will split you very fastly. So this method train underscore test underscore split method will split your records in a order, in a standard order. It was x train, comma x test, y train, y test. But you can keep a b c d. But you should know a is a train rate of x variable, b is the train rate of y variable. And I want to do one more thing, right? So before that we have to assign the what is x and y, that we have forgot it. So data dot head of 2, right? We have to assign what is x. What is the x input feature from pregnancy to age? So this all I should assign to x. Outcome I should assign to y. X equal to I can put df, right? Df dot ilog of, I should take all rows. And what is that? Here I could put -1, which means that this is -1, -1, -1, -2 till to age. We got it. And I'll be defining what is y equal to df dot ilog of, I should take all the rows and I wanted the last one. That's it. All right, so you can see what was there in the x till to the age, and similarly you should check what was there in the y. It's only outcome. Now I come here, I'll call them method here, and we have to pass what was your x and y. So I have to pass x and y. My test size has to be fixed. Test size is actually what, I could say 0.25. All right, come on, random state, which means that randomly the records are going to be selected. You can pass any integer. All right, now that's it. Now we can see x train dot shape, we can see, and x test dot shape. Similarly y train dot shape, same 576. All right, y test dot shape. All right, so we have splitted the records. And uh, model model construction. So the logistic model is being constructed. So we have to call the algorithm from sklearn. So from sklearn dot, since it is the linear model, because linear regression and logistic regression both will be in the linear model package. Import, so logistic. 1 minute, it is loading. Because you don't need to type everything, so because sometimes there might be a typo if you do manually. So call everything from the, press tab and it will be listing out. So now log rec equal to logistic regression, right? And then so we have to train the data, train the model. This is what I'll be calling out. I'll be just calling the algorithm and assigning to the log reg object. So when you call and execute the log reg, it is only simply it returns the algorithm. Now we have to train the model. So how do we train it? So I'm going to call logreg dot fit. Fit is the method to train any model. When you want to train, we have to pass the train data. So x train, comma y train, right? So once the train, that's it for the training, right? So once the training is done, we have to test it. You can see here the star indicates it is, the training is happening, right? Yeah. So since I haven't updated a lot of packages, so that it gives a warning, right? So I go with testing. The train is done. I'll do test. What is test? I'm going to predict. So logreg is the object, dot predict is the keyword, wherein which we have to pass the x test. We'll be giving the y test, and you know you can put y prediction. So the input of what was there in the X test, their outcome is going to be stored in the Y prediction with the help of this trained model. Logreg is a trained model. This predict is the keyword to take this input, and it has to gone through all the way of the trained model. Then outcome is being stored into the predicted outcome is being stored in the Y prediction. That's what I have done it. All right. So now, because we don't know how many correct classification are there, how many wrong classification are done, we have no idea, right? So that we want to evaluate the performance. Evaluate the performance. So evaluation, as I told before in the initial session, evaluation is done, right, with confusion matrix classification report. I try to import all the packages. It was there in the matrix from SQL. Then call the matrix module and import your confusion matrix. 1 minute, just finding the appropriate method. It is not coming out. Yeah, now we got it. Confusion matrix, comma classification report, comma accuracy. All right, it's all needed. So now I'm going to call one by one. So print of accuracy score of logistic regression, right? I could call it as a accuracy score of, we have to pass the actual and predicted. Actual data, actual y was stored into y test, the predicted was stored into y prediction. So that's it. Similarly, I have to call the confusion matrix and so on. Confusion matrix, Same actual was stored into y test and prediction was stored into y prediction. And similarly, next to confusion matrix, we have a classification report. So I'll be calling the classification report. Then we had to pass the actual and predictor. That's it. We'll be executing. You can see here the accuracy is 76 percentage. Confusion matrix, classification report. All right. So let us take what is the confusion matrix, and we'll be do some kind of discussion over it. Okay. So confusion matrix. So generally, it takes we have actual, we have predicted, anything you can take. So actual was 0, sorry, 0 1, no, let me take a different color. So it's 0 1, similarly 0 1. All right. So what is the value we have here is 118. Okay, 118, 16, 30, 28. All right. What is the test records that we have in it? Test records 192 is the test records. So test record is 192, because out of the test records only we will be finding the performance. So here um, let us take here I don't want to like, so 1 minute, let me take this side as the actual so that it will be much convenient for me. So actual, predicted, fine. So the actual was 0 category, the predicted as a 0. This is what? True positive, right? So what is 0 actually? 0 is no diabetes, that I can say it is a positive, that I'll be referring as a positive. All right. What is 1? It is a negative. 1 is they have diabetes. So this is positive and this is negative. All right. You can have a, okay, right, fine. All right. So now uh, this 0 is positive. The prediction is also positive. All right. So you'll be passing 192 records. What is the, how many records are there? 192 records will be passing your trained model. Out of that, 118 is predicting correctly, 0 is positive. So predicting correctly is the true positive. Am I right or wrong? True positive. So predicting correctly. So here your actual was 0 and predicted was 1, right? So true negative. This is misclassification, right? Your actual was 0 positive, your model is predicting negative, How many records are predicting negatively? 16 records. True, positive, true, right? Sorry, this is false, right? Sorry, it's a false, right? Come here. Your actual category is negative, but your model is finding positive, right? So this is the misclassification is the false positive,
त्याला क्लिक कर. हां.
right?
मध्ये क्लिक कर.
Then this you can come here, come up here.
समजलं?
This 28, right? This was negative. Actual thing was negative, and your predicted is also negative. So this is what true negative. So this always this region like this diagonal is the correct
रेड हँड केलं
classification.
त्याची स्टार्टिंग काम करत
This opposite diagonal is the misclassification, right?
1 second, participant, someone has unmuted there. It is okay now, no? Hello?
Yeah, yeah.
तिथं असलं पाहिजे ह्याच्यातच पाहिजे चार्ट बंद केलं त्यातच असते त्यात त्यांनी चार्ट डिसेबल केलं ना डिसेबल केलं त्याच्यातच असतं पहिलंच ऑप्शन असते
Okay.
नाही बाबा गुगल मीटच भारी गुगल मीट भारी तुझी पण भारी
Sorry, sir. Can you unmute yourself since I muted all the participants? I couldn't find out who was.
Can you hear me now?
Yes, yes.
Yeah. So this was the always this diagonal is going to be the correct classification. The actual was exactly classified as predicted. So I could say it's the correct classification. All right. So this 30 and 16 are the misclassifications, that is false positive and false negative. I could say this is the type 1 error, right? So in machine learning, we have been classified. This is the type 1 error, false negative, and false positive is the type 2 error, right? So what is the objective of any model is when you go for a optimization, we have to reduce the numbers in this type 1 and as well as the type 2, which means that false positive and false negative, right? We have to reduce it. So that's the reason why we go for a hyperparameter fine tuning, right? Hyperparameter fine tuning. So let me calculate how the performance are being done. You can see here, let me take accuracy, how the accuracy is going to be calculated. What is this? This is what true positive plus true negative divide by true positive plus true negative plus false positive plus false negative, right? So you can see here, I'll be finding what is the true positive value, 118, right? This is 118 plus 28 divided by all together 118 plus 28 plus 30 plus 16, if you could say. And anyone, you can, if you have, you can answer it. 118 and 28. I'll take a calculator. Even if you want, you can calculate it. 118 plus 28, this is 146. I know this, the entire data is actually 122. This is the test data, 192. All right. So now calculate it, 146 divided by 192, you can see 0.76. That is the accuracy score of the model. As such, it is going to be calculated. Right. So you got an accuracy. What is this? And now I'll spend some time on our classification report. All right. You could see here precision, there is a precision recall fn score support. Always the precision recall value should be equal for your both of your categories. How many categories do we have? 0 and 1. We have two classes. For 0 we have 80% precision For 1 we have only 64%, and you can come back to the recall value. So recall value for 0 is 88%, whereas 1 is 48%. Similarly, F score. What is the reason? What is the reason we have very low precision recall for one category? Is like we have a less number of records that belongs to one. That is the only problem. Already we have told you when we are doing EDA, this target variable is unbalanced. So for 0 we have almost 560 records, for 1 we have only 250 records. So it was unbalanced. That's the reason why you'll be getting 80% for precisions, which means that your overall performance is 70, but always the zero, the high amount of chances is good for only for 0 category, not for 1. Sometimes your actual outcome should belongs to 1, but it is being classified as 0 since you have lot of evidence for 0 category. So what I'm concluding here is when you start with unbalancing data, then you have the higher amount of chances to predicting always the higher amount of records data. So the one category is not being classified as good as how you'll be classifying as 0. All right. So that is the conclusion that I'm going to convey here. All right. So okay, so I go with the QA part. Almost the time is 11:45. So if I start doing the further answer, it takes me time. So I have just completed how intelligent model is being built and how you have to take up the how you have to deal with the data, and I've just demonstrated how the data should be understood by the developer. What kind of sense you'll be understanding from the data by just plotting some of the graphs, right? And then how you take forward the data into the model building, how you'll be training and testing, and how evaluate the performance. So I've done my part, so let's go with QA. Any questions? So I'm very glad that if I receive any questions from you all.
Participants, questions or any questions you have, please post in the chat box. So one query is there posted by Bhavesh.
Yeah.
How can we show the values of confusion matrix in the percentage or chart? You have already explained it, right?
Yeah.
Okay, okay.
Okay. Yeah, already I've explained.
So any other queries? So shall we wind up the session then? We can join back, sir. Afternoon session, maybe they'll ask the doubts.
Yeah. Okay.
Yes, sir. So for the participants, we'll have an exam after the afternoon session, and that will be around 3:30. At that time, all of you will be shared a quiz link, MCQ link. So you have to attempt and score above 60% for that for the test. So see you again at 2 p.m.